Perfectionists are the ones who are lazy. Okay, so anyway, so welcome to summer semester 2020 twice. That doesn't mean 2040, it's just 20 with two twos. Oy vey, it's going to be a long night. So this is chapter 11 from the 6th edition of MATLAB for Engineers, written by Dr. Holly Moore, who is on her way tomorrow morning for a fun-filled week in Hawaii, and she's not taking me with her, the dirty pig. No, I'm not bitter. Okay, so anyway, so this is chapter 11 on different kinds of arrays. For me, this is the chapter I struggle with the most. I mean, I can do it, but it's not so much, for me, it's not understanding how to do these things. It's remembering which one has a parenthesis, which one has a square bracket, which one has a curly bracket, which one has a period. I just, I barely remember my name in the morning, let alone all these fine little intricates in the syntax for this chapter. But I'm getting more gooder. Okay, so, yeah, that's me. Hi, welcome. Okay, so anyway, let us move on. Work, you pig. There we go. So the learning objectives, you should identify different kinds of data used in MATLAB, and there's a bunch of different types. You should be able to create and use a variety of different types of numeric arrays, chars, string arrays, specialty arrays, including logical date time. Date time is pretty cool. I never seen that until I read this chapter. That's pretty cool. Categorical. That one's kind of nifty. I think the PowerPoint doesn't get too deep into that, but the textbook does, and I think that could be an interesting one to learn a little bit more on. Create multidimensional arrays and access data in those arrays, and create and use cells, structure table, and timetable arrays. So that's a lot of stuff to learn in just a short 45 minutes, hopefully half an hour. Okay, 45 to 50 minutes. I haven't been under 50 minutes the entire time we've been doing this. What am I talking about? So, introduction. I introduced myself 8 weeks ago. This is MATLAB. Primary data types in MATLAB is the array. That's what we use the most. Back before 6th edition, it was called matrices. But now, because matrices is supposed to be divided mainly to those arrays that are all numeric, and you can have other arrays that are various different data types, the string, the char, dates, and just all kinds of stuff. So arrays. They can also be called classes. And we got some block diagram type things coming up here in the next slide to show you the hierarchy, or the you might as well just go to bed. You can't even think straight. Anyway, so within MATLAB supports different number or different secondary data types. It's written in C. Mostly contains data type of a single type. That's one of the data primary types. Stored in multiple types, and MATLAB functions to convert between the types. So there's a lot of number to string, table to a structure, and there's a lot of different functions to convert back and forth between the different types of arrays. So here's the MATLAB. A diagram showing the different types of data stored in MATLAB arrays. So under text, you have your characters and string, your logical, which is basically zeros and ones. The numeric fall under the integers, where there's you have multiple signed integer types and unsigned. Your floating point, which go into a single precision or double precision. That's basically we'll cover that in just a minute. Then you have your complex, which are your imaginary numbers and real numbers. The categorical type, which is kind of cool. We'll touch briefly on that in PowerPoint. Time, you can do a date, time, duration, and calendar duration. you enter two dates, and it'll tell you how many hours there are between the two dates. Symbolic, we won't touch on too much in this chapter because chapter 12 is devoted on symbolic mathematics. And then function handles. There's also MATLAB array types. There's a single data type arrays, which is categorical, text, logical, numeric. Sparse arrays, we'll cover that in a few slides. Time, symbolic, and function handles. Then there's multiple data types, which are your tables, your say arrays, structure arrays, map containers, and timed tables. Okay, I don't remember map containers coming up in this chapter. And then, as I've said before the recording button started, MATLAB, or at least the textbooks that we're using for MATLAB, is trying to push away from the cell arrays and the structure arrays and focus mainly on tables. And then these are obviously dealing with dates, times. Cool. Farm out, right arm. You like the nice pretty colors? Isn't that cool? Wow. I could stare at that for at least 5 seconds. Okay, so numeric data types. There's in the textbook there are 4. This only lists 3, and I know this because on one of the practice exercises, I left off one word as I was reading it at the beginning of the problem, and it says to do something with all of the data types, and so I went in. I did it for the double precision. I did it for the single precision. I did it for all the integer formats. And the one that's missing here is the complex formats. I couldn't find a way to do it for that one. And then I went back and read the problem again, and it said to do just on the various types of integer products. So I did extra work and didn't get paid for it. How sad is that? Okay, so anyway, so data types. So the first data type is double precision. This is the default format for which MATLAB type. You enter a number in, it just defaults to a double. So it says here, notice the information of each in the workspace window. So yeah, so this one is set up to show you how big the storage is for each type. So each single digit, it takes 8 bytes of memory to store that digit. So where B has 10 characters, it's going to be 80, and this is 2 by 3 is 46. Okay, say that's cool. Yeah, wow, that's cool. So if you want to find out what the biggest number that you think that MATLAB could do an infinite number, but no, it has a maximum value where it if you went to 1 over that, it would give you not a number. So to find the maximum real numbers, use real max, and real min will give you the smallest number possible. That's essentially 0. But those are the largest numbers that can be stored. If larger than that, assigns a value of infinity. Okay, not a number. I lied. It's infinity, not a number. So it just means that it's just way too big for the capacity of MATLAB. And same thing with if it below the minimum number, it assigns it a value 0. But I mean, what's the difference between 0 and 2.2251 times 10 to the negative 308? That's a very, very. I don't think even Lemin would use that kind of precision in her calculation. Sorry, she's my data analyst. Very, very precise. So anyway, so there's your maximum minimum size for double numbers. A single precision floating number it only uses half the storage space as a double. And so thus it only stores half of the information. What information it leaves out, I don't know. We'd have to get in deeper to find out. But it only requires 4 bytes instead of 8. You can use a single function to convert from a double to a single, and then if you want to go back to a double, you just do your double on your single. So there's 2 of the conversion functions that we touched on earlier. And you can get the same max and mins on the single using real max and real min as we did on this one. See, that one did real max, real min. and this one's real max, real min. So those two functions work the same. Why you need that other than general knowledge, I don't know. And I tried, although very briefly. Oh well, we'll get to that in a minute. So here's the single precision. See, it only these are D is single, so single 5. So that 5 is by default a double by putting it in the single function. It makes it a single, so you can see here single, and it only takes 4. So here's your real max. You'll notice that this only goes to 10 to the 38 instead of 308. So it's a significantly smaller number. But the one problem with the single is the rounding errors. Today's computers have plenty of storage for most of these numbers, but going into single precision may lead to round-off errors and problems. If it doesn't show you in here, I can show you a problem that I found, and I reported to Holly that she needs to update her solutions for the practice exercises because I don't agree with her practice exercise solutions. But it's something that'll show you the rounding errors in single versus double precision. Okay, so onward, round off error. Oh, here we go. So actually, did this actually show it? So this is actually one of the problems in the practice exercises, taking a harmonic series and finding the sum of all the digits between the first element and I think it was 10 million. But as you can see, this just keeps getting bigger and bigger and bigger. It just diverges and never converges to a certain value. It just keeps getting bigger. And so it gets so big to the point where it's zero. It doesn't make, there's no increment between one calculation and the next because it's just so big you can't calculate. So this is a cool function that I've seen that in the book that I never knew about. Oops, go back. Is CumSum. It's a cumulative summation. If you have a single array, it'll add consecutive values. So like if you had an array of 1 to 5, the first digit would be the first sum, the second digit would be, and you're setting these to another, it'd be the sum of 1 to 2, and then 1, 2, and 3, and then 1, 2, 3, and 4, and then 1, 2, 3, and 4, 5. I think that's pretty cool. I mean, that's something that would definitely replace a for loop, because you could just, instead of doing a for loop, creating vectors, and yeah. So anyway, I got off tangent. So this calculates partial sum of the series, the sum of all the values in array up to the element number displayed. So this one here, so in this example, they're going to show this on the harmonic series in both a digital and a double and a single precision numbers, and see the difference in values. Let's see here. So this section of code performs double precision numbers. And where's the output at, Holly? And then this one does the she didn't show an output on the values. So she calculated the harmonic series based off of double numbers and single numbers, single precision numbers, and then plotted the same two on a plot, and here you can see the difference. At a certain value in the single precision, it just basically stayed at the one value because it was adding 0 every time, whereas in the double precision it's still adding just a little bit every time. So that shows the difference between single and double precision and the rounding errors. This is an effect of rounding errors on a single versus double precision. Sorry. I'd like to say that's vodka, but it's just straight water. Okay. So the next integer numeric data type is integers. Let's see what it says here. It says all the double precision floating point numbers are the default integer data types are also available. You can use integers for counting. Obviously, like I say, you can't have 2.5 people in a room. You can't have find one element number 1.5 in an array. So to save storage type space, again, a lot of these were dealing with the computers back in the old days when you were really excited that you got a half meg memory on your computer. Trust me, I was there. I was one of them. I just, wow, I got a half meg on here now. Oh, yeah, okay. Anyway, so there are 8 different types of integer numbers for which you can get. They differ in how much storage space is allocated and whether it's signed or not. And the more storage space, the larger the value number you can store. So here are your types. So there's an 8-bit, a 16-bit, 32, and 64-bit. These are all signed, and these are all unsigned. So the digit refers to the amount of storage in bits required for each value. So, yeah, cool. Farm out, right on, out of state, and all that other good stuff. Since 8 bits equals 1 byte, E requires 1 byte of storage. And E is int 10. So the maximum number you can have in an 8-bit system is 127. Of assigned, and this is an unsigned, is 255. Because yeah, it takes more to store assigned than it does the unsigned. Use int max to determine the largest number of value to be stored each data type. The 4 signed integers storage space specified by a number is plus or minus. So see, it takes more space to keep track of positives and negatives. And then the unsigned just is basically the absolute value. So it just stores the number. It doesn't tell you whether it's positive or negative. Farm out. So complex numbers. I alluded to this earlier. I spent a lot of time, maybe 10-15 minutes searching MathWorks website, trying to find out what the maximum and minimum size of a complex number is, and I couldn't find it. I could find all kinds of things about complex numbers, but I couldn't find the maximum, limit of complex number or the minimum. I even asked Holly, and she said, I never thought about that. So it's one of the mysteries that'll plague mankind for years to come, or until one of my students figures it out for me, like they did using the underscore as a character in a string array. And my Lynn was really happy when I told her about that. Anyway, so complex numbers can be stored as singles and as ints. And obviously, it looks like it can also be stored as a double. Cool. Right on. Okay, so character and string daters. We've covered the character and string a bit in earlier chapters. So text data is stored in MATLAB as either a string or a character. String data type was added in release 2016, so that was 6 years. So technically it's like 10 or 11 versions of MATLAB, because there's an A and a B each year. So it's been a while that it's been out, and it has numerous advantages over character arrays. You're dealing with one element instead of one element for each character in the string. Storage space is less, but a lot of the legacy code still uses characters, but going forward you should use string for all of your programs. It'll still accept either or, but Holly textbook is stressing that it's bestest to use the string format. Yeah. Okay. So, creating string character and string arrays. String quotes, well, single quotes can be used character array and double quotes for string array. And see, and when we first get into this, my only two functioning brain cells had a hard time remembering, okay, is it single for string and double for quote? And then I finally figured out a way for me to remember this. I mean, if it's a single quotation, it goes to a character, because character starts with C and that comes before S in string, so alphabetically. So one quote goes to character and two quotations go to a string. So I got that one narrowed down. Cool. Yay me. Woohoo. Woohoo. Okay. And double quotes are used for string arrays. I just covered that. Character array stores each individual element. So these are character arrays, so this one is going to be a 1 by 7. This is double quotation, so that's a string, so it's 1. And then there's also these functions that will convert things from character to string and vice versa. Okay, cool, farm out. Two-dimensional character arrays, because characters stored in individual characters and because arrays need to be rectangular stored, it is always awkward. Trying to create a two-dimensional array with characters, they either have to be the same size or you have to use padded technique, padding of empty spaces in the array with blanks. And that's easy enough to do, I think. Yeah, it's easy to do. There's an example here. So I'm not sure who Jasmine is, but I know Stephen is Holly's husband. David's her son. Terrell is Stephen's last name. I don't know Manuel and Sarah. I think Sarah's one of her kids too. Anyway. Yeah. So here we go. We do it a char with all the names in single quotations separated by a comma, and it pads it. MATLAB automatically pads it and adds spaces at the end of the shorter names to fit the length of the longest name. So now these are all 7 characters long. They just have spaces in them. And then to create a cell array of character arrays, use a cell array constructor, which is the curly brackets, also called curly brackets. See right there, or braces. Semicolons are required, so you have to put semicolons betwixt all your inputs. So this stores each one as is and removes all the excess spaces to make it fit. Ooh, I gotta hurry. We're on cell 22 of 93. Okay. The same techniques used character arrays and string arrays. String arrays more memory. Strings require more memory than equivalent character arrays. However, arrays of strings require less memory than characters stored in cell arrays. Okay, so that's nice. But it's just the same way. So if you're doing string arrays, you use square brackets. Characters are curly brackets. Strings are square. And this one here, this will say each one is only one element. So it doesn't matter if one's longer than the other. Okay. Character encoding strategies. That word right there. Yes. Strategies. Okay. Zeros and so yeah. Okay. This basically is telling you that the computers, I know you'll find this hard to believe, but computers operate off of ones and zeros, on and off, binary system. And there are 2 major coding schemes to do this. There's the ASCII2, which is one we're mostly familiar with in this course, and then there's this EBCDIC, and one of the I don't know if it's homework or practice exercises asked you to look these up, and I did. I put it in a web address in my homework assignment. So it basically assigns a number for every character, and then that number is a decimal number for each character, and then that number is converted to binary so that the computer can read it. Yay. Okay, so here's the binary code of the digits 1 through 8. So that's 1, 10, 11, 100, 101, 110, 111. I would find it hard. Well, I don't know. I'm sure you've seen this binary stuff prior to this video, because we live in a binary age, or at least digitally. So every ASCII character has a binary representation, and to find it, you just plug in double the number in single quotation marks, and it'll tell you. So the ASCII code for an A is 97, and I'm not sure if this, but to get the capital A, you have to subtract 32 off of that, so 65 would be the capital A, and you can get that if you put that into the char command. Put char 65 into char, and you should get a capital A.
Good question, Art.
No questions. Oh yeah, sorry. What's up?
Why 97? Is there a reason, like the lowercase a is 97, or is that just
in the ASCII2 code, the format? And I'll show you the diagram that I found earlier. It's just an industry standard that in the ASCII2, 97 indicates a lowercase a. And
okay, so it is something that is connected to the lowercase a, not just an arbitrarily assigned number for that variable.
No, in any computer programming you get into, an ASCII code 97 represents a lowercase a. So here we did char 98, which would be 1 more 97, a more plus 1 is b. So by putting char 98, it turned 98 into the ASCII code for a lowercase b.
Do you know where that comes from, or why that is? Or is it just something that's
it's just something been around since they started computer programming. You know, back in the old days.
Thank you. I appreciate the clarification.
Nope, no problems. That's what I'm here for. And I'm happy. I think I know the answer to that one. So, okay. So here we go. So when a char function is used on a double character, the character represented by that decimal number is returned. And there is one of the problems. I can't remember if it was homework or practices. That's the problem with doing both of those in the same day, as I don't remember which one's which. But you have to change lowercase MATLAB to an uppercase MATLAB, and I did it 2 ways. But you're supposed to do it in nested functions. I did it in a for loop, and then I turned around and did it in the nested stuff. Okay, so combine a character and numeric information temperature. MATLAB converts all data to character information. So here, you take the character A and add a 98. It just automatically generates the ASCII code for 98 and makes it AB. If you didn't have the single quotations and you had some value for A, it would plug them together in a row. But assuming A was a single row vector. Okay, cool. Form out right on. Notice that A is a character, and then B is a character, and C is a double. Oh, that's because we took, so what we did here is we said C is A plus 3. So A is a character, and we added 3 to it, and it pulled up the double number value of that, which is 97, and gave us 100. Okay, so yeah. Okay, so hint, strange characters behave differently, operator performs different functions, so yeah, so we just covered that. And if it's a string array and add a 3 to it, it just puts a 3 in, giving you a new string. Okay, symbolic data. We don't touch too much on this because chapter 12 is just chock full of symbolic mathematics. But symbolics do both function handles, symbolic variables. We can create equations, solve equations, factor equations, do all kinds of fun stuff with equations using symbolic properties in MATLAB. So yeah, right here, see, so symbolic toolbox is discussed in a later chapter. It's not too much later because it'll be the next lecture. So to create a symbolic variable, use a sims command, which is sims x. Now x is a symbolic, and you can write it out in an equation, and it's kind of cool. So here's an example to just symbolize. We created x as a symbolic character, so now x to 2 minus 2, it's basically assigned that in an equation. But yeah, we'll get into more detail on that in chapter 12. Cool. Logical data. Again, this is something it's not necessarily new to MATLAB, but it's new to our course because there was a long time between the 5th edition and the 6th edition. But logical data is zeros and ones. So so here, so zeros, ones are true, zeros are false. So by doing this, it just converted it to a logical array, and you can see it takes more to store the character as a double than it does a logical. Say that's cool. Wow. Farm out, and you can convert a double into a logical with the logical conversion function. Say that's cool too. Wow, that just blows my mind. Okay, logical arrays are usually created as a result of logical operations. That just, yeah, okay. And we covered some of this in the previous chapters. So z equals x less than y. So if it's true for that, you get a 1. If it's not, you get a 0. So cool. So I'm not going to go over something we've already learned. The find function uses logical arrays as inputs. We put in comparison at the end of the function. Yeah. So here we got an array to find those 1 through 5, and y is these odd numbers, and z is going to be the values that are less than, or sorry, where x is greater than y, so that returns a logical array of 0, 1, 1, 0, 1, and then find z, and it returns the values up here in y that are less than x. Which is 2, 3, 5. 2, 3, 5. This is not the values themselves, it's the element numbers 2, 3, 5. Okay? Got that? Don't get confused on that. Okay. Then you can use this to go back and get numbers. X squared plus y. The value of w is only calculated for elements where z is true. These slides would make a lot more sense because I'm trying to interpret what Holly wrote. I did go through this array before, or slide PowerPoint before, but yeah. Okay, sparse arrays. So what the sparse does is if you have an array, a large array that has lots of zeros in it, and you don't want to store all those zeros because it's so large, you can use the sparse array and it'll remove all of the zeros, leaving all the other numbers in place and their locations. So here, this built an identity matrix of 1,000 by 1,000. So that's a lot of data points. So here we have 8 million bytes to store that data, but by using sparse, it still has the same values, but it's considerably less in size. Cool? So yeah, that's cool. Okay, categorical arrays. This one is kind of cool, but I'm going to have to get some. This is brand new to me. I've never even heard of it before reading the textbook. But it stores information from a finite list of categories, similar to a logical array, since the elements in the logic can only be either true or false, and the elements in the category array must have one of user-defined list of values. There's an example of it here where it created W as a categorical of A, B. These are test scores. Obviously not for my class, because none of my students would be getting D's, E's, C's, or B's. All I got all straight A students. So it created that, and then so it's stored as a either can be used as either a string or a character arrays. Either one doesn't matter. It's still stored. But then what do you do with it? So if you want to find out what the grouping of the letters in here are, so it goes through, and even if there's multiples, it comes back with these are the list of values that are in there, even though some of them may be multiples. So if you want to find out how many or what position all the A scores were, you do find a W equals A. So it goes in here and it finds, okay, there was an A in 1, and down here A in 8. Okay, and this you'll need to use this on problem 11.24. Yeah, so cool, right? Yeah, say cool. Okay, so time arrays, forming calculations with date. Yeah, and this guy, I've never seen this before, this edition either, but it's kind of cool. It'll take a date format, and make it so that it's more legible. Every month has a different number of days, years, leap years, complications. Time isn't based on a unit of 100. So MATLAB stores time information in a date time array. There are multiple ways to create this. So here is an example. Find the duration between two dates, February 1st, 1990 and May 20th, 2016. So we created the years, months, and days, and then we use the date time function to create dates off of the years, month, and day. So that created a 2x1 array of February 1st, 90 and May 20th, 2016. See, isn't that cool? So yeah, that's cool. I'm hoping you're saying these at home while you're watching, because if not, I'm sure wasting my time telling you to say these are cool. So you can find the duration. Between two, you just subtract the two. This is the time in hours. So there's 230,520 hours between May 1990 and February 1990 and May 2016. So cool. Any questions on that? No? Cool. Okay, so Denver climate data. I was currently working on that one. That's problem 1125. I ran out of time before I had to start this lecture, so I didn't get it finished. But there's some stuff here in this presentation about that data. So you'll notice that the month is set up here in 2015 0101, and this is 1201. So each month, so they apparently took a temperature reading on the first of each month and recorded the temperature. So this is kind of hard to read. First one, so import the data. Ooh, I need that. Oh no, back up. Okay, what slide is that? 44. Remember 44. Hike 44. Okay. So we can extract the data from the spreadsheet, and then it goes through a couple of ways to import the data. To double click on the Excel file in the current window, and go through the import wizard, do column vectors, import. You can select which data columns you want to import, so just taking the date and this, because that's what the problem was asking for, and then import them into MATLAB, and then they're there. Say, look at that, wow, that's cool. So you don't have to import the whole thing, just what you want. And then you can and see, Holly, that needs to be red and in a square. Hey, they 46. If the date is stored as double, the resulting labels are difficult to interpret. Let's see, here's an example. See, it's hard to see what. That just looks like gibberish to me. So by coming in and using the date time and convert from year, month, day, which is the format that it came in, it'll put it into this, and then when you do the date, it prints it out in something that's more meaningful. So isn't that more gooder? Say, yeah, man, that is just totally tubular. Okay, format. So it can be interpreted as plotted. So the Orlando data. So here's another one that because the dates were taken at different intervals than this here. The plots look really yicky. So, oh, and you didn't go into that, Holly? Why did you come to here if you didn't finish it? But read this in a book. It's really cool, because you can use the date time. Yeah. Anyway, it's more gooder. So multiple dimension arrays. I'm going to go through these really quick because, like I say, they're trying to push away from these arrays. But basically, what it's doing is, if you look at each of these stacks, that's what we're used to dealing with. This is a row by column, and then the multi-dimension means that I have several of those in one variable. So these are rows, columns, and these are called pages. So each page is a different set of arrays. And then you can take a whole bunch of these and put them into another dimension, fourth dimension, called drawers. We don't get into drawers. In fact, we're trying to bypass pages, going strictly to tables and chairs and place settings. Okay, so anyway, to create a three-dimensional array, suppose you want to combine all four of these variables into so 1, 2, 3, 4, 5, 6, 2 by 3 by 4 variable. So you'd have 2 rows, 3 columns, and 4 pages. So you'd create those, and then you would come here and create your name file, your variable name, and then parentheses, all the rows, all the columns on page 1 is going to equal X, so it assigns all those to X, and then all those on page 2 to Y, all these to page 3 for Z, and all those to page 4 for W. So they have to be defined separately. You can't do it all in one step. You're now listed as a 2 by 3 by 4 array. And that's what it looks like. So it shows you each page individually laid out. An alternate approach is to use the cat function, which concatenate the arrays which follow in order. Yeah. So the squeeze function is if you have a multidimensional array where one of the elements is just a single, you can use a squeeze and remove that and squeeze it down to a normal two-dimensional one. Cells arrays are pretty much the same as the multi-dimensional arrays, but you use the curly brackets and see, and this is where, you know, so here we use parentheses. Here we use so we got our multiple variables that we're trying to put in here, and so now we're using the curly brackets. And I'm sitting in the corner going so they can be kind in an array with the cell array constructors. And notice the resulting array lists in workspace as a 1 by 4 cell. Okay, so indexing into a cell array. Indexes used for cell arrays is the same as that used for other arrays. Yeah, sort of, kind of. Okay, yeah, right. You may either use single index or a row column indexing scheme. Each element in the array, a cell array, is an array. The result of an internal array of parentheses to turn around. So here we created the cell array back here. With all that data in here, and then we come over here and we want to see cell array 1. So it's going to bring back 1, 2, 3, which is A, 1, 2, 3. And during this brings it in as a cell array. If you use the curly brackets, it just displays it as 1, 2, 3. Other than that, I don't think there's any difference, but I could be wrong, because I are stupid with a capital stu and a little peed. So to access a particular element inside of a cell array, you must use a combination of curly brackets and parentheses. So this is telling it to go into my cell array, look on the 4th page, and give me the first row, second column, which is 2. Say that's cool. Confusing, but cool. So here's one of these commands where you can convert a cell to a table. Why are we into tables? We haven't even started tables yet. Well, we better hurry, because what time are we? 48. Wow, we're pushing this. Similarly, if you really need the cell array, you use this table to cell function. Again, we're trying to push away from cells and structures and go strictly to tables. So here's the structure arrays. They're similar to the, but just a little bit differenter, because you have this dot. So my structure dot some numbers, and it's equal to A. So this will be the page number, is some numbers. Single dot, this is structure. This is one field called some numbers. Notice in the structure, which is, so you know, so each page will have to be defined individually. So you got some letters, some strings, and some singles. So each one has to have the structure name, dot that, and then what you're assigning to it. And then to pull something out, so here is my structure 2, which is going to the 2nd page, some numbers, and then this is adding content to the structure and expand its size by adding more arrays to the fields that we've defined. So this is adding more numbers. Your standard, again, this is so much more complex than using tables. Some of the fields are empty, just a single field. So if you want to get more details on structure arrays and cell arrays, contact your local MATLAB dealer. Meet them in the alley late at night, and they'll give you the down low on that stuff. But search MATLAB, search Google, go to mathworks.com. But again, so table arrays. Holly told me to skip through that stuff really quick because we're going to focus on table arrays. So we're on table arrays. So this one's been around since 2013B, so that's almost 20 editions ago that they introduced the tables. And we didn't know what they were. We just thought it was a neat way to build a table for displaying and for putting in fprintf. And then Holly found out that no, there's much more gooder things we can do with tables. They can be stored, grouped into data types, the special use for tabular data, such as that stored in spreadsheets. Creating tables from workspace variables. MATLAB includes simple data that can be demonstrated. So there's a lot of this stuff that you can get. Before creating tables, some modifications should be made. The data set, so last name variables is just arrays which has some memory, the location of the places, and finally we create the table. Just okay. So this is again, this is a sample that Holly has in the textbook that you can go through, loading up a file that's called patients, and the last names, the location, and T that makes a table out of the last names, locations, whether they're a smoker, and what gender they are. So double click in the variable name in the workspace opens the T array. So you can double click over here on this sucker and open it up and add more contents and edit it. So here's the data that's in that file, and you can see there's a whole bunch of it because it's I forget what size was that. Oh, 100. So there's 100 rows in there. Indexing into a table array. To index into a table, use the same strategies as used in numerical arrays. Specify row and column. To determine if page is smoking, this corresponds to row 2 and 3. So basically, we've created this table. We look at T23, and it tells you whether the smoker would be false. And the names that raise the tables function can be okay. And see, and this is all stuff that we've done before creating tables. You list all of the variables that are going to be put into the table, and then if you want to name the variable columns something other than the variable names, you list them in string values and square brackets separated by commas. Now you can either do it like this, or you can put it down here and make it all into one. You can put all this down here and then make that so long that it ends up clear over here on my counter. Oh no, get back on the computer. There we go. But I did find out today, as I was struggling through 1124, don't put spaces between here. So if you got last name, that's got to be one word. You can't have spaces, because it really screamed at me, and I fought it and fought it. Why are you doing it? It works, it works, it works, it works. And then I finally took spaces out. Wow, it really works now. So yeah, no spaces in the names. Good, so a rows in the table array can be assigned names. Oh, that's cool. That's not in the textbook. I don't remember reading that in the textbook. One row has been assigned. Rows can be extracted using row names and a column operator. Oh yeah, okay, so I vaguely remember something in there about using the properties to do something like this. Row names is equal to the last names. So each row will be assigned the last name. So if you want to find Johnson and all the information on them, then you do this. That's cool. Yeah, so Johnson was in the VA hospital, who hasn't been a smoker and is the male gender. Multiple rows. Gotta make sure you use the same substitute row names for numbers. So if you're going to do multiples, you got to have the inputs in square brackets. Again, this is assuming that you use the properties to rename your rows to the last names of your data file. Get out of there. Okay. Cool. Column indexing. Similarly, portions of the table based on a row and column names can also be extracted. So, you know, if you want just the hospitals, you don't want all that other information, you just put what you want in the next comma. So it's rows, comma, columns. Sorry, I got something tickling my eye that's stuck on my glasses. Whoa, man, those glasses are dirty. Okay, so creating arrays from data files. We've done this. We've imported data files from Excel into MATLAB. There is the using the read table function is one way to do it. It reads its file, and oops, there's also the UI import command. But somewhere, I don't know if she's put this in the, where we at? We're at 77, we're getting close to the end of this thing. The summary function gives more, it includes the names of the columns, so you can use summary on the data file and it'll tell you what's in there. So patients, readable, read table function. Also this use the read table, the data in, changing the data type. There can be asked you to call some dot syntax. So here you got T2 dot last name string, gender, self-aware, self-assessed health. So yeah, so it's just, you know, yeah. Oh, here's the user UI import read table. So this one was something I'd seen in the textbook that was kind of cool. That if you want to set your import up, creating, yeah. So so the UI, when you do the UI import, it opens up the import window. You can make your decisions based off here where you want comma delimiters, table or columns, and all kinds of other, you know, it's the same stuff we've been doing before. As you examine, you notice drop-down menus on the column headers. Then you can, yeah, the drop-down menus here, you can change the type of data that's coming in, either text, categorical, numerical, and that's all. You know, there's also string and character, and in this case, arrays, logical arrays are not an option, so we can't change the smoker array data to logical, but we can change it to a categorical names. So you know, you can set all of your variable or your numerical types before you import it. Once then, after you've made all your changes, you can come over here and select the blocks, import data. You should say name patients. Patients. Okay. Creating. There we go. Generate a function. If you select generate a function will be created, and with your choices that you've made here, and this could be used with future data sets to automatically to automate the data manipulation, so that you don't have to go through the import every time you come into this type of data file, which would be great for what I do at my office, because I'm always using the same format of data that I'm analyzing, and I wouldn't have to do it every time. I could just come in here and create. Well, I wrote my own function to do it, but it'd been nice to know that this was here instead of me spending hours and hours to write my own program. Oh, but look at the learning you got. I know, but man, that was, oh man, we're an hour. Okay. Timetable arrays, we covered it a little bit. They're to MATLAB's time to data. This is experiment with timetable arrays is stored in CV, so it can be loaded using the read timetable. So yeah, if you want to learn more about the timetable stuff, look it up in the book or on the website. Two different sizes of arrays. Synchronizing timetables. Okay, so yeah, so here we had two different timetables, and let's see, did it do the plotting? Nope, it didn't. But it's pretty cool. If you look through the book, it synchronizes it so that you get a much more gooder plot. It does a linear interpolation, and it's really cool, really neat. Farm out, right arm, out of state, all that other good crap. So one more improvement here, close examiner of the time. Okay, yeah, hourly spline summary. So summary, I just did an hour and 2 minutes worth of talking, and I probably spewed out more garbage than the garbage man picks up on Tuesday mornings. So for what it's worth, yeah. You got any questions? Was any of that even useful?